All right, so we're working on the XFLR project. So first thing we'll do is we're going to go and download the Clark Y airfoil, and we're going to go rearrange it so that we get rid of those titles and then it goes in the correct direction. I always like to tell that the 0, 0 is there. So that's good. I just know it's named Clark Y web. And so we're going to go file. We're going to start with direct foil analysis. Then we'll do full screen. Then we will come down and foils. Let's see. There we go. Foils. And desktop. Clark Y web. And there it is. Yep. And I'll have to change the color, just make something wacky so it's easy to remember. All right, so we have our there foil in there. So what we can do is then we go to File, XFLR Direct Analysis. Then we will go to, let's see, we'll go to Analyze, define an analysis, type 1, Reynolds number. Let's add a 0 in here, make it 1 million. Then mock number 0, encrypt can say a 9, 1 and 1 can say a 9, click OK. And then we will do file, direct foil, and sequence. I messed something up. And -5, 20, 1, and analyze. And now we've got our graphs. So now we will export them. So we'll make sure we get them. So we'll start with, this is our CL versus alpha. And you can go to current graph, export graph. So this will be Clark Y CL versus and drop this into my folder. And we'll come over to this one. We'll make this one our CL over CD versus alpha. Click OK. And current graphs, export graph. This will be Clark Y CL over CD versus alpha. That's better. And then now we'll do CL versus CD. So we'll do CL versus CD. Okay. And current graphs, export graph, and Clark Y CL versus C, and save. Let's see. So once we have those, I'm gonna minimize this for now. Come over to my files, and we'll open them. with this, I can make it a graph. So, all right, once I get all of them, all from this and then the foils, I'll make a graph, but you'll see that later. So, stop recording. All right, so now I'm back. I'm done. I just was organizing an Excel file, but we'll come back here, and the next thing we're going to do is start making wings instead of just a single airfoil. So what we'll do is we're going to go back to File, down to Wing and Plane Design. We're going to click on the little plane here. I don't care about you right now. And then we're going to click on Analyze. Oh, hold on. File, Wing and Plane Design. Click on the plane. Plane, got it. Define a new plane. So this is going to be Clark YAR 4. First, so we can get rid of the elevator, get rid of the fin. So it's going to put, we're also going to put AR for B. I'm going to calculate it, so we'll do B, it will be 0.36, and we'll have a C of 0.18. And so now we're going to define the main wing. Actually, get this bigger. So we're going to come down here and we're going to make our wing, our chord. So I'm sorry, our wing span is going to be 0.36, and our chord is going to be 0.18. Oh, and I'll set 0. And we'll double check over on the right. Yep, aspect ratio 4. And yeah, wingspans 36 times 2, 72, so that's perfect. We're going to choose our airfoil, make it the Clark W. So now it has shape. Dihedral 0, a twist of 0. Okay, that our airfoil shape. Give this 0.36 also. Fuck. One moment. And we're back. I'm not going to do that again. So we have our foil made exactly like we did before I fucked it up. Click save. And we got our elevators again. Yep, click save. And so this is our airfoil. Looks wonderful. So now we are going to click analysis, define an analysis, type 1, that's fine. And LLT, that's fine. Click save. Now we're going to click on this little sideways looking graph, and we're going to come over here, and we're going to make it the CL versus alpha. Okay. We'll make this one CL over CD. Oh man, there's a lot of options here. CL over CD versus alpha. And then we're going to make this one CL versus CD. Okay. Oops. The only problem is we actually have to run it. So we're going to do a sequence from -5 to 20, 1. Click analyze. Click close. And we're going to try to solve that problem and be back to you. All right, we're back. We changed our velocity to 3.4 meters per second. Hopefully that'll work. And we're going to click save on that bad boy. -520, change of 1, click analyze. And it's outside the flight envelope. Log. Crap. All right, so what we did is we went back to our scroll direct analysis. Went to our analysis, batch analysis. We changed it from 100,000 to 1.1 million for our Reynolds number. That's what corrected our issue. Then we came back to export the plane and wing, reran it from -5 to 20, back at angle of 1 at 83 meters per second. And now we got our graphs. So we make this CL versus alpha, that's good. We'll check. This is CLC versus alpha, good. And this is CL versus CD, good. So we're going to export these. Current graph, export graph. This is going to be arc AR4 CL versus alpha. And save, current graph, export, arc Y, AR4. This was, I don't remember, CL or CD. Okay, so now we go into our plane, make a new one, find a new plane. This is going to be our AR8 and 8s. Get rid of that, get rid of that, get rid of that, fine. Make it our airfoils, and already calculated the sizes, 0.72. Chord length will be 0.18 again. Offset will be 0, that equals 0, and perfect. And double check over here, aspect ratio is for 8, save, and save. Come back to our plane, and click analysis, define analysis, and keep it all the same, and analyze. Alrighty, so now we come over here to our graphs. And let's see. Well, guess we're getting them all. All right, well, you get the point. I'm going to go through export all of them, and then I'll get back to you in Excel. All right, so now what I'm doing is I'm just going to create, I exported all this data into separate files here. I just organized it here so it's easy to put it all into one spot. That's what I have. So now I'm going to come over here, data, I'm sorry, insert. Let's choose the scatter plots. Okay. Select data. And we're going to double check. We want alpha to be on the x-axis. Select. Do that. Oops, I'm sorry. It's going to be y. Select our x-axis. Select our y-axis. Click OK. We're going to edit that because I don't know why I gave it a stupid name. I made it a stupid name. That's going to be 4. Perfect. Now we come over here. We'll add on the axis title, chart title, and data labels. Oh, not that. I mean, looking. And this is going to be CL. This is CL. This is L. Yeah. Yep, so I'm just going to do the same thing for all the graphs and I'll get back to you. All right, I'm just going to pick up because I got to get off. So I've come over, I've got all my data organized in here. I'm a graph for each one. My max CL for each wing and airfoil along with critical angle of attack. I've done that for each thing. I need to do it for CL over CD. Actually didn't ask for CL over DCD, so I'm not doing it. Then I have the graphs over here. I'll pick up more later. Okay, so I'm going to finish up the rest of the project. Left off earlier after doing the lift and drag stuff. Just going to give a brief rundown of how I got the rest of the results. So the lift and curve slope stuff I got using the equation from the notes right here. I used this one because we're greater. This is less than 4. We are at 4 and higher. So I went to the subsonic high aspect ratio. Calculated the Mach numbers using the temperature that was set in XFLR 5, which is 15 degrees Celsius. Came out to like a Mach number of, let's see. We know where it's at. Came out to a Mach number of 0.236. And then use that to then calculate the AIC for a compressible. So have the max coefficient of lift, max coefficient of drag for everything and all that stuff. The zero lift drag component, what I did was, let's see, it told you to do it based off of one of them. Oh, the lift versus drag. So I went to each one and found where the coefficient of lifts takes zero, and then right there, right there, right there, and right there. And then just interpolated to get those for our zero lift coefficient of drags. And then the overall induced drag coefficient, let's see, I imported some data from XFLR 5. Got like the induced angle of attack for the wings on each one. Exported those all to Excel here. So now the variation of the induced drag over the wingspan and the induced angle of attack over the wingspans. For each wing, just threw the graphs in there and then moved those over to my results. For the induced angle of attack, I came over here. It says the top. Oh, and this was all at 7 degrees, by the way, for what I was just showing. This for 7 degrees, I brought it down, calculated this coefficient of induced drag, which was using the equation CL squared over pi ARE. Did that for each one. Then I calculated the induced angle of attack, which is CL over pi AR. Did that for each one. And then I went and calculated the downwash. Well, then changed these to degrees here. So this is really the answers, degrees. Yeah. And then for downwash velocity, I struggled with it a bit, but I think I figured it out, and I had to do it by hand because it was not working. I just did based off of a triangle using the induced angle of attack, the free stream velocity of 83.4 meters per second to find the downward component. So this was omega infinity, so W infinity. So essentially the equation becomes V infinity times tangent of alpha I equals omega infinity to get me those numbers. And then plug them in. So now I have everything in here, and I believe that is everything I need on the project, because I can now mark that this is done. We're going to go over real quick. I have my 3 graphs mentioned above for CL versus alpha CL over D versus alpha CL versus CD. Then lift curve slopes. I have maximum CL and angle of attack, maximum CL over CD and angle of attack, zero lift drag coefficient, overall induced angle of attack over the wingspan, induced angle of attack, and downwash velocity. So yeah, that looks good to me. Yeah, well, like